In Module 7.1, we want to spend some more time talking about the derivative and the information that the derivative gives us, or the information that we can pull out of a function to better understand the behavior of our graph and what's happening to it. So consider this function below, f of x equals x cubed minus 3x. We want to look at where this function is increasing and where this function is decreasing. So just tracing along the graph or reading along the graph from left to right, our function is increasing anytime the graph is headed up, decreasing anytime it's headed down. So we've got this first interval where our function is increasing. Then we hit a point where the graph changes direction and starts decreasing. And then again, we hit another point where the graph changes direction again and turns back into the increasing portion of that function. So we can look at describing that behavior by constructing a sign chart for the first derivative of our function. So what we should be able to identify here is that at this point where our function changes from increasing to decreasing, there's an instant there where we have a horizontal tangent line. And the same thing when our graph changes from decreasing to increasing, we have a horizontal tangent line. So anytime we have a horizontal tangent line, then the derivative of our graph is going to be equal to 0 at that point. So in this case at x equals -1. And then again at x equals 1, our derivative is going to have a value of 0. Because again, whenever our derivative function is equal to 0, that means our tangent line has a slope of 0, so the graph is horizontal for just that instant. So going back to these ideas that we looked at in earlier modules when we talked about limits, once we identify those zeros, now we can just look at these intervals in between to see where is our function increasing, where is it decreasing. So our function is increasing on this first interval up till we hit x equals -1. So our function is increasing, the value of our first derivative has to be positive. When our function is decreasing, the value of our derivative would be negative. So we know on that interval from -1 to 1, the first derivative is going to have negative values. And once we get past x equals 1, our function is increasing again. So our first derivative would have positive values. So what we're interested in this module is constructing a sign chart for the first derivative, which would then help us understand what the behavior of this graph is. So here we've done that backwards. We started with the graph, use that to construct the sign chart. But in general, what we want to do is construct the sign chart so that then we could understand the behavior of the graph for all values of x. And specifically what we're interested in finding to do this is finding the points where our function changes from increasing to decreasing. Because everywhere in between our function continues the exact same behavior. It's either strictly increasing or strictly decreasing, except at these points where it changes direction. And those points where our graph changes directions are referred to as critical values. So critical values are values of x where our first derivative is equal to 0. So we found a point here where our first derivative is equal to 0 and a point here. So those are critical values. Or the other case to consider is where the first derivative does not exist. So if a function changes from increasing to decreasing, that's going to happen at a critical value. However, we need to keep in mind that functions might not change direction at critical values. So for instance, what we have below is the graph of y equals x cubed. this function is going to have a horizontal tangent line at x equals 0. So at x equals 0, our first derivative is going to be equal to 0. And then if we look at what's happening on either side of that critical value, as we approach 0 from the left, our function is increasing. As we approach 0, or as we continue from 0 on to positive infinity, our function is still increasing. So in our first example, x equals 1 and negative 1 were critical values. So those were critical values, and at each of those critical values, our function changed direction from increasing to decreasing. In this example, x equals 0 is still a critical value. But in this case, the direction of our function didn't change. Our function leveled out and then just continued increasing. So to understand where our function changes directions, we want to find these critical values, but then we also have to look at the behavior of the graph on either side of that critical value, because they don't necessarily guarantee that we found a value where our function is going to change from increasing to decreasing. So those last two examples both dealt with cases where the first derivative was equal to 0. But if we consider the function absolute value of x, then we can look at a case where the derivative of our function does not exist and see how that's also still a critical value. So if we construct a sign chart, again, for the first derivative, we talked a few modules back about how the absolute value of x at x equals 0, that derivative is going to be undefined. And you can look back in your notes, but again, the idea basically just comes down to the idea that our function is decreasing as we approach from the left and increasing as we approach from the right. So our function can't be increasing and decreasing at the same time. So our derivative is undefined or does not exist. So I'm just going to mark that with an x rather than a 0. And then we can look at the behavior of our graph on either side of that critical value. So in this case, as we start with negative infinity and approach to 0, our function is decreasing. And then from 0 to infinity, our function is increasing. So here, x equals 0 is a critical value. In this case, because the first derivative at that point is undefined or does not exist. So it's a critical value. And in this case, it's a critical value where, again, our function does change direction, does change from increasing to decreasing. So in general, to find critical values, the first thing we need to do is find the derivative of our given function, and then solve for where that first derivative is equal to 0, or the first derivative does not exist.